Problem number 7, we see y is equal to 2x plus 3 divided by the quantity 3x plus 2, and we're asked to find the derivative. So this is another quotient rule. So we want to, and notice right away we see option A, which says derive the top, derive the bottom, and call it a day. There's our close confusion that we don't want to fall for. That's definitely out. We know the quotient rule is bottom d top minus top d bottom all over bottom squared. We know we're going to have a 3x plus 2 in the denominator, and that needs to be squared. That means it's option B, C, or D. So the question is which one? Well, let's take a look at it. Bottom means we have 3x plus 2 starting off our numerator. D top, derivative of the top. Derivative of 2x plus 3 is just 2. Minus. Now we keep the top, so 2x plus 3, and we derive the denominator, top d bottom. Derivative of 3x plus 2 is just 3. So we have a lot going on in our numerator, but that's it right there. We're going to need to simplify that. Doing so means we have to distribute the 2 and the negative 3, because that negative sign right there as well. So 3x times 2 is 6x. 2 times 2 is 4. Negative 3 times 2x is negative 6x. Negative 3 times 3 is negative 9. I'm just going to focus on the numerator right now because I know the denominator is going to stay as is. 6x minus 6x is 0. 4 minus 9 is negative 5. We want a numerator which is negative 5. Problem number 8. We have the graph of f of x, and we're told it's 4 line segments. Up, down, up, down. Which of the following about f is false? The limit as x approaches 0 of the function minus f of 0 is 0. Well, let's find, we know that this is subtraction inside a limit, so we have to look at the limit as x approaches 0 of the function, and then we also have to look at the limit as x approaches 0 of f of 0. So the limit as x approaches 0 of the function. This is our finger test. As we approach 0 from the left and the right, we see that we are heading towards 0. So this value right here, that's equal to 0. Now we need the limit as x approaches 0 of f of 0. F of 0 is 0. When we plug 0 into 0, we get 0. So 0 minus 0, which in fact is 0. So this is true. We're not going to choose option A. Option B, we have the limit as x approaches 0 of f of x minus f of 0 over x is equal to 0. This is, if I put a minus 0 right here, this is our alternate form of the derivative. So this is saying the derivative of the function at 0 is 0. Okay? The derivative of the function at 0 is 0. So we're interested in f prime of 0. Okay, well, f prime of 0, that would be the slope of the tangent to the curve at this point right here. But as we know from our differentiability issues, the derivative does not exist at a sharp point. So f prime of 0 does not exist. But this says f prime of 0 is 0. That is a false statement. So our answer is B. Now, C and D are obviously true. Really quick, let's check why. Alternate form of the derivative, this is saying the derivative at 2 is equal to 1. This is saying f prime of 2 is equal to 1. Here's x equals 2 right here, and sure enough, the slope of that line is 1. So that's a true statement. This is saying the derivative at 3 does not exist. Well, here's the point 3, 3, and at that point, we have a sharp point, so in fact, f prime of 3 does not exist, so that's true as well. Last but not least, we have this, let me scroll up just a touch here. Okay. We have another function, f, which is defined to be x divided by the quantity x plus 2. At what points on the graph of f, there's a property that the line tangent to f, so tangent, we're thinking derivative, so when is the derivative, well, tangent has a slope of a half. When is the derivative equal to a half? So this is a little bit backwards. We're not plugging a value into the derivative. We're trying to figure out what value or values will cause the derivative to be equal to a half. Before we can answer this question, we need to get the derivative. So let's do that. F prime of x, x over x plus 2, that is another quotient rule. So we have x plus 2 being squared. All right, so in the numerator, bottom d top. So the bottom is x plus 2. The derivative of x is 1. You don't need to write it, but I will. Minus, now we keep the top, and we derive the bottom. The derivative of x plus 2 is 1. So we have x plus 2 minus x. X plus 2 minus x. We can see that the x's cancel out, so the derivative of f is 2 over the quantity x plus 2 squared. That's f prime of x. We're interested when x is equal to when that derivative is equal to a half. All right, so we have this equation we need to solve. Fraction equal to a fraction. What's our process? Exactly, cross multiply. X plus 2 squared times 1 is the quantity x plus 2 squared. 2 times 2 is 4. All right, we want to figure out what values of x cause this statement to be true. We can take the square root and subtract 2 and everything, but let's use our mental math here. We know that we need this to be 2. All right, because this is 2, then we square it, we get 4. If this expression has to be 2, then we know that x has to be equal to 0. However, this expression could also be negative 2, because negative 2 squared is 4. So what value of x plus 2 is negative 2? And the answer there is negative 4. So we're interested when x is 0 and when x is negative 4. This is when x is 0. This is when x is 0 and 4. This is when x is 0 and negative 4. That's our solution.